So for our differential equation to model the bike throw, we chose to use a basis off of a mass spring constant using the human body as the spring and the bike as the mass. So for our starting equation, we used the value of 10 kilograms as the bike, 75 kilograms as the person. So we put 10 kilograms x double prime plus the drag resistance on the system, which will include the spring, which is 259 newtons x prime, minus the constant of the spring, which we found to be negative 37.5x, and this will be equal to 0. So to start, we had to get our roots, our root 1 and our root 2. To do this, we use the quadratic equation, getting a root 1 of negative 26.04 and a root 2 of 0.14. After this, since both roots are different and real, we used x is equal to c1e times the root 1t plus c2e to the root 2t. After this, we got c1e to the negative 26.04t plus c2e to the 0.14t. To get our initial conditions, we had to take a few logical steps. We decided that the x position at 0 would be 0 meters, as that would be the finish line, and the x prime position, since x prime is velocity, x prime at 0 would be 18 meters per second. So we have c1 as so we have c1 plus c2 is equal to 0, which gives us c1 is equal to negative c2. Translating that into our x equation, we have x is equal to negative c2 e to the negative 6.04 t plus c2 e to the 0.14 t. Then we take our x prime is equal to 18 meters per second, and we take the derivative of the right-hand side of the equation. So we get 18 is equal to negative c2 multiplied by negative 26.04 plus c2 times 0.14. This gives us a value of 18 is equal to 26.18 c2. So we get c2 is equal to 0.688 and c1 is equal to negative 0.688. Since the amplitude of the system is the displacement of the spring mass as the spring mass system, we found the amplitude to be equal to the square root of negative 0.688 squared plus 0.688 squared, and we got the amplitude to be 0.97 meters. That means that 0.97 meters is the displacement of the bike in the system, which means that the bike will be 0.97 meters ahead of where the rider will be. At the end result, since we have an amplitude of 0.973 meters, we had to check this between a basic physics problem just to see if it was justifiable. So we used a conservation of momentum of the 75 kilograms of the rider multiplied by the original 18 meters per second of the system, plus the 10 kilograms of the bike times 18 meters per second of the system. Then we used the new velocities of 75 kilograms of the person multiplied by 17.9 meters per second, which we got using a kinematics formula. And once we got this, we found the velocity of v2 to be 18.75 meters per second, which is a reasonable speed increase, and that gives us a push forward of 0.75 meters. So by displacing the rider of negative 0.1 meters, we pushed the bike forward 0.75 meters. We found this value to be reasonable, so we found our equation correct. Since the displacement from the throw is 0.973 meters, and the bike travels at a speed of 18.75 meters per second after the throw, we can deduce that the optimum throw time is 0.05 seconds before the rider hits the finish line. We deduce this by dividing 0.973 meters per second by 18.75 meters per second.